I'm going to talk about the encryption scheme of information in CUDA applicable to RTGS payment systems. Well, we're going to build on these points. We are going to talk about the high performance of payment systems, the characteristics of our new payment system, the encryption mechanism we have implemented, and we are going to answer the question why GPU accelerated and why ACE CTR, the next steps of course, and why we are ready to face the future. Well, high performance for payment systems. You know, a payment system is any system used to settle transactions between its banking institutions. So in Mexico, we have a nationwide payment system known as SPAY, or Interbank Electronic Payment System, based mainly on a DNS scheme. In the end, the clients or the customers or that banking institutions are people, just you and me, people who want to transfer money to a familiar, to a friend, and use these payment systems in order to transfer money. Well, this system, SPAY, was completely developed by personnel of Banco de Mexico. And now, because the amount of payments we have to process actually is increasing, we are now currently working on the design and prototyping stages of a completely new payment system. This payment system is going to be a hybrid payment system that is going to, we will have the ability to process payments on RTGS scheme, additionally to the DNS scheme of its antecessor. Well, the big difference between RTGS and DNS is that RTGS, the payments just pass through the system very fast, and just the only condition that is taken into account is that you have to have the liquidity to pay that payment. And DNS, it's somehow different because during very little segments of time, around 3 seconds, all the payments are put together in order to maximize the liquidity, but somehow it takes time this process in order to settle the transactions. Of course, an RTGS scheme is faster, and a DNS scheme is a little slower. Well, the main characteristics and main requirements of the design of the SPAY2 are, of course, high level of security, a high throughput, and a high availability. Well, our first goal to achieve in the inception and prototyping stages we are actually working was the security mechanisms. Of course, security is very important. And we focus on encryption information. That's because actually is one of the most CPU demanding process in our payment system, the antecessor of SPAY2. And of course, we focus on that just to see if GPU is going to enable us to go faster. Well, our design is based on symmetric keys, which are delivered through a PKI, or public key infrastructure, during the login process. So we ensure the system will be protected against man-in-the-middle attack intended to obtain the symmetric keys. Well, the mechanism implemented, as I said, the starting point is the login process, in which through a PKI we encrypt the information we want to send to this login process, ciphered through the public key of our participants. So with the public key of our participants, we encrypt information that is the counter of the server, the counter of the participant, a seed that is going to be used to differentiate between its participants, and the symmetric. Then it's sent to the participant, and the participant is the only one who can decrypt the information and obtain the symmetric keys. Well, once the participant has completed the login process, every subsequent message to be sent to the participant to the system and vice versa is divided into 65 blocks. And through this scheme, we divide the information, the message, in chunks of 16 bytes. Each one of these blocks are related to one nouns that is the same for the entire message, just one nonce, and a counter. So this is the way that we can ensure the information it's going to be encrypted faster, okay, faster. Why? Let me show you this. Somehow we just need an encryption block. The encryption blocks is the blocks that are going to encrypt our information, and the same blocks can be used to decrypt information. One CUDA core is used to generate one encryption block. So if you see what the only thing we need to generate the encryption blocks is an ounce, that is once per message, and initial counter. That is the only two information that we need. So we just pass the ounce to the GPU, and the counter, the initial counter, and a CUDA core can encrypt and generate our encryption block. Then all the encryption blocks are sorted with the information decrypted or encrypted in order to generate the information encrypted or decrypted. So the message is, as I said, encrypted using just XOR operation with encryption blocks. These encryption blocks are generated in a parallelized fashion through the GPUs. Okay? Somehow it's advantageous, this scheme, because we don't need to transfer all the information to the CPU, from the CPU to the GPU. We just generate encryption blocks. That is the most important thing. Why GPU accelerated? Of course, because it's very advantageous just to generate encryption blocks simultaneously. Well, we used ACE CTR, of course, because ACTR is an algorithm of encryption that can be parallelized against CBC, against ECB, that those algorithms are not parallelizable. So CTR is very, very, very parallelizable. And of course, its level of security holds. Well, next steps for our payment systems. Well, as I said, encryption of information is not the only process we expect to accelerate through GPU computing. The process that we are going to accelerate to is electronic signature verification, net settlement or acceleration of the knapsack problem, that is a very complex algorithm, and of course, fraud detection. And let me tell you that approximately 60% of the main processes of our new payment system, SPAY2, will be accelerated through GPU computing. Well, in Banco de Mexico, our nationwide system, SPAY2, will be able to process a very high volume of operations, specifically more than 100 millions per hour. This is 10 times the calculated maximum burst of demanded operations in the next 15 years, and around 1,000 times the power of the actual system. Well, based on the projections of demands and the model of